So we've proven that machine learning can be done on the Arduino Portenta, at least on the M7 core. And I should probably make one that proves that it works on the M4 core. It's just a little more confusing because serial is a bit confusing on the M4 core. The M4 core can actually handle a bigger model, and that's something we also did was the layers example, which allowed you to load larger and larger models on your microcontroller. Well, right now, what I'd like to do is I call it the digital. So on my GitHub site about Portenta, we go to my TensorFlow section and go to the digital one. You always click on raw and just copy it, and it's pretty fast. Copy. I've already got this saved, and I've already got Portenta M7. I always check. There's the M7. It's actually the one that says the Portenta. And so let's get that going because it's actually really slow to compile. You should do something while it's compiling. Anyway, what this is, and most of my stuff I use JavaScript to sort of get going, and this is my set of JavaScript machine learning. And the digital one's right here. And this is kind of what someone with a microcontroller might do in machine learning. So I've got an example here. Say you have a light as one of your sensors. So 0 is no light, 1 is light. So it's a light sensor. And then a rangefinder, same thing. This is all digital. Moisture means 0 means there's low air moisture, 1 means it's okay, etc. And then for CO2 and temperature, I've set it's 2-bit. So 0, 0 is now low, 0, 1 would be okay, 1, 0 would be high okay, 1, 1 would be too high, etc. And that really is data you could get from a microcontroller. And then I've got pretend actuators here. We're doing four floating point number outputs. This is actually reading it as single point, but they're actually floating points. So these are digital, they're an analog version. So you could be turning things on and off with a range, like a motor to a certain speed. Anyway, it's kind of explained here, and you can test it out and train it. The big deal is we can save to disk. And once it's been saved to disk, you could load up something like Gitpod. This is all fully pre-made. I have a pre-made example here where the thing I save is a model.json file with its weights. And this bash file here does 3 lines. It converts it into a Keras model. Then it converts it into a TF-Lite, TensorFlow TF-Lite model. And then this last line converts it into a model.h, which is what your C or C++ program needs to run on a microcontroller. So what I'm going to do here, I'm just going to copy, oops, wrong one. I'm going to copy the model.json and the model.weights into my folder. I've got my folder activated right here. And you see there's the model.weights, the model.json. And we're just going to watch while I run this batch file. So this is not something we need to, well, it'd be nice to understand, but it's not necessary to understand it. For some reason, I can't type a 0. I'm just running this batch file, and let's watch over here. So that batch file is first taking model.json and creating some assets and a Keras file. Then it's creating a model.tf-lite file, which is all in binary. And then it makes the model.h, which we've seen before. There, that's already been labeled as a model.h. And way at the bottom, is there a quick way to go down? It's got a length. And this is actually pretty small. Okay. So this program, which is still compiling, let's go through it. Same as all my other programs. You first load that thing we just created from the JavaScript program. And as I said, it does the conversion all itself. I've got quantization working, which makes it much smaller, but it's a little bit more complex. So we've got our model file, and this one's a different one. It's been trained. And we've got our TensorflowLite, and some includes, some are bracketed out or commented out because they're for more advanced programs, but they're there. And then here it's defining to run on the M7 core. It does nothing but the default, but for the M4 core, to be able to print to serial, it has to do something fancy. And on the Arduino Chow, it has to do something fancy there. You could have it do something fancy, which is nothing, which is the else statement if you're running a board that doesn't have any of these. And setting that up is a bit of a pain. Then we've got our namespace. Then we've got our model setup, which simply calls this thing we created. Then I've got model.predict, which really is just returning the interpreter invoke, which is going to be 0 if everything's good. These lines are here to identify that it's using a reasonably advanced pointer for input and a pointer for output. Well, I used to try to pass the information here and get the information out, but it got too complex. It was like you needed to make a new library for every single thing we did. So we are going to do something reasonably advanced with those pointers. Here we're just setting up red, green, and blue. Here we're setting up the model. Remember, this is the model. That's the thing that's made away from the microcontroller. Actually takes a fair bit of computer power. And then I'm doing some random numbers, throwing those random numbers. These are just 0 to 1. This is a fancy modulus thing that makes a number from 0 to 1. And I'm setting up an array called myInput. Now here, I'm grabbing the 0, 1 from my input and putting it into this pointer. Now I could have put it into the pointer directly, but I think there's some advantage to having a myInput array. And then here it is. This is the only line that's run. Just like in JavaScript, you're doing a model predict. We're grabbing something from it, and this is 0 if it's good. And then I'm grabbing an output, and here once again, you could just use this information. I could set this with a for loop. I just want to show you, I'm just grabbing the 0 output and putting it in my output 0 array. The 3 output, putting it in my output 3. There are 4 of them starting with 0. And then we're testing those. If it's greater than 0.5, if the first output's greater than 0.5, we set the red onboard LED to low, which on the Portenta weird makes it light up, and high if it's not. And then if number 1 is greater than 0.5, these numbers are from 0 up to 1. We do the green one, and then we do the blue one. And the fourth bit of information coming out, we're not setting anything. Unfortunately, with the Portenta, with the onboard LED, I can't do a range as easily. If you set up a PWM LED, we could actually just set it to the range, and then you would have bluer and darker blue, lighter blue, and same with red and green. It would be a little prettier. Then we're printing out 0 if all's good. So it's printing out the string with the predicted. That was the one that basically tells you it worked. And then what is it doing here? I ignore that line. This line is going all 8 inputs, and it's just doing the inputs, my 0, 1, all the way up to 7. And then it's doing the 4 predictions. So red is doing the my output 0 and 1 and 2. And you could have done this whole nasty looking pointer thing, but I've just chosen not to. And I didn't upload the latest version of this. This is probably going to die. I'm going to pause, make a brief little change right here. I think that line is too long, and come right back to it running. Okay, that one did actually run, but here I've just split it into 2 lines. On my school, not as good computer, it died on that one. Let's see, we got it flashing. And it often says it's crashed because of the port, but no, we've got the port right there. And we go to serial monitor, and here we go. So what's it done? 0 if all is good, return prediction 0, all is good. All 8 inputs. So here are the digital 8 inputs that were sent. I can't remember what the first one was supposed to be, but this is the kind of thing you would get from a microcontroller. Say it was a range, you would have to figure out, whether you did 2 bytes or 3 bytes or 4 bytes to represent a range. Anyway, let's stop the scroll. Well, actually, we need to auto scroll so you can kind of see. This one at the moment is flashing blue because blue is considered to be pretty close to 1%. Now it's flashing red. Anything over 0.5 here, this other one isn't used at all. So it should be red and not green or blue. And this is where the machine learning comes in, is it can do a mix of them. This time it's blue because that's over 0.5, but it's also green. So that is not the typical blue. That's the typical blue. Okay, so it is running. The concept is these are the inputs and 8 inputs. And here are the 4 outputs, of which 3 are affecting the board. And it seems to be working. Now, reality, if you were doing this, you would then have to train your machine learning model to make sense of all that information. So on this Roxetta site, it describes it all, and you would have to get data. And so here I've got the training data. If everything was 0, the target data is those 4 outputs. These could actually be in decimal form. It takes in a floating point. And so you would need massive amounts of data to train this. And that's where machine learning models are potentially powerful, because they can get a sense of these 8 inputs. It could be 12 inputs. It could be 600 inputs need to have these outputs. And to begin with this is where you know the answers to some of the things. You have to give it information. And so that becomes the hard part of machine learning. Anyway, I hope that's been a little bit of a demonstration, and have a good night.